All right. Might as well pick up with where we left off. Remember we did this problem with the squares here?
Yes.
And the area was 3/4, the shaded region, 3/4 of the area of either square. All right, let's look at this one. So if we draw our 3, 4, 5 triangle,
Uh-huh.
you know it's a right triangle. That's the smallest perfect Pythagorean triangle. The perimeter of that is what?
Is it just 12?
The perimeter of the similar triangle, which is it has to be a bigger, same thing. It's not a 3, 4, 5, but this perimeter is 36. What's the similarity ratio?
3.
3 to 1. Whenever I talk about the similarity ratio, I like to think of it as the bigger versus the smaller. So it's 36 to 12. And what that means is that every side on this bigger triangle is 3 times the size of that smaller triangle. So what are the dimensions of this bigger triangle? Instead of 3, 4, 5, what is it?
Is it 12, 15, 9? So then is the answer B?
Yes. In other words, the shortest side, well, that's always the 3 side. And in this case, it's the 9 side. Okay. '24, pretty common subject. In other words, by that, I'm talking about difference of perfect squares. That's what you're looking at here. Now, they tell you what A minus B is, and they want to know what A plus B is. How do I solve for A plus B? So I got to solve for that right there.
Okay. Would you just plug in a 20 for the A minus B and then just...
Now what? So now I have 4 times 20 times A plus B equals 40. What does A plus B equal?
You just divide it? 20 or 2?
Solve that equation for A plus B. How do I get rid of the 80? What's the 80 doing right now? The 80 is a multiplier, correct?
Uh-huh.
So what do I need to do to get rid of it?
Oh, I do 40 divided by 80.
Which is That answer is not
0.5.
on there, but there is an answer on there that's the same number. Okay, good.
Okay.
Always make sure. That's a fairly common error that I see. When you have a problem like that, a lot of people do 80 divided by 40 instead of 40 divided by 80. Number 25. Don't be fooled by the complexity of their statement. Very easy problem.
Do I just plug in the 1900 or set that equal to 17x? Well, just that equation.
Yes.
Okay.
In other words, we know what the profit was. Well, profit is given by P. They're saying that it was 1900. So here's what we start with. P of x equals 17x minus 10x plus c. Okay?
Okay.
Now, they say 300 units were produced. So P of 300 equals 17 times 300 minus, don't drop any parentheses yet. Okay.
Okay.
Now, they're also saying that P of 300 is 1900. So it's 1900 equals, well, what is that? That is 5700 minus, that is 3000. And this negative sign has to apply to that plus c also, which makes it minus c. Now we have 1900 equals 2700 minus c. I get minus c equals minus 800. C equals 800. Well, I did something wrong. This little right there was a mistake. That is not 5700, that is 5100.
Oh.
So that's 2100. That's now 200. E is 200, positive 200. Now, what's another way I could have solved this?
Another way?
I did it completely algebraically. I started with the formula they gave us, plugged in the 300 units, plugged in 1900, and solved for C. Totally algebra problem. In other words, I didn't need multiple choice. Multiple choice was worthless to me, except for one thing. What did the multiple choice point out? Pointed out a mistake I'd made in my math. I came up with a C of 800 and there was no 800 on the list. So that tells me something. So the multiple choice was not worthless for me here. But in general, it was. In other words, I didn't use any of the techniques that we might use, like back solving. Now, this is not perfect for back solving. But if you put the 300 in first for x, then it kind of is. You can go through and see all 5 of these answers and see which one works for C. It's got to satisfy that equation right there. In other words, there is your ultimate equation. And you can either solve that for C, or you can try their answers and see which one works. If you happen to back solve it, you will get that as the very first one. This is not an ideal problem for back solving. And one of the reasons is that if I were to try a C of 100 as my first, remember you always start with B or D when you're back solving. The problem is if I start with a C of 100, I don't know for certain which way to go if it's not the correct answer. I don't know if it needs to be bigger or smaller. And whenever you have a problem like that, it's not great for back solving. Back solving is terrific where when you can pick one of the answers, and if it's not correct, you always know whether you need a smaller or a bigger number. Notice these go from largest to smallest. And they usually will go from one direction or another. Sometimes, usually they go from smallest to largest. This is actually a little unusual in that it goes largest to smallest. All right. When do you take your ACT test?
Tomorrow.
Okay. Well, I don't have to worry about having to do more of these. Let's go back. Let's jump up to test 3. What I'm looking for is a lot of medium type problems. Easy to medium. We don't want to demoralize you. So we don't want to give you a bunch of tough ones right before your test. So, no, I'm serious. There's something to be said for you feeling really good about your math skills going into that test. You want to be confident. You want to know that you know what you're doing.
Oh, true.
Okay. So, let's start with 9 here. On this is the test 3. We were just on test 2. So,
is the answer C?
Good. Number 10. They want to know, hold on. Sometimes that is annoyingly slow. They want to know this angle right there. Tell me how I'm going to get that angle.
Well, so like using the 135, subtracting that from 180, that one angle, wait, no.
You're right. What is this angle right there?
Wait, I did that. So that angle is 45.
Okay. That helps.
And then if you do the same thing to the other one, the top one, that's 70. So 70 plus 45 is 115, and then subtract that from 180. So then that inside, so then angle G,
hold on,
or Q.
I didn't do that right. Huh. 115, that's 65, right?
Yeah.
Okay.
So then you could just subtract that from 180. So then you know angle Q is 115.
Okay. And that's correct, and that's a perfectly fine way of doing it. Notice there is a pretty big shortcut. The shortcut is this exterior angle is always equal to the sum of the two angles that it is not in a linear pair with.
Oh, okay.
In other words, if I know that angle is 120, and I say, what is angle 1 plus angle 2? It's 120.
Okay.
And that's called the exterior angle rule. as opposed to having to do it just slightly harder. You had to get one additional step where you had to find that angle, and then you had to determine what was supplementary to that angle, which is fine. Just whenever I see a big tip that I can give you, I try to.
Okay, thank you.
And how about number 11?
Okay. Well, you just have to distribute them all, right?
How do you multiply a binomial term by another binomial term? It's binomial because there's two terms.
I thought you would just do the square root of 2 times the square root of 2, and then square root of 2 times -4, and then -6 times the square root of 2,
Perfect.
and then -6
You're foiling.
times.
That's
Yeah, FOIL. That's what it's called. I'm sorry.
Okay, so give me the answer. Term by term. What is that again?
So square root of 2 times the square root of 2 is square root of 4.
Which is 2.
Yeah, so 2. And then -4 square root 2. And then -6 square root 2. And then positive 24.
Okay, now I don't see that answer on there.
So then you have to combine the -4 and the -6 and with the square root 2. So then would it just be -10 square root 2 plus 26? That's not one of the answers.
Which answer is that? That is an answer, actually.
Is it just in a different form?
No. Just got.
Oh, did you just add?
That's all. In other words, it put the number first.
Oh,
this is perfectly legitimate as an answer, and I wrote it that way because that's the way you told it to me, but I also wanted you to see that the answer does not have to be in that exact form. It just has to be the same number.
Okay.
Number 12.
Okay. So do I just distribute the square to all the numbers?
Well, tell me what you mean. I don't know what that means.
So would be x squared minus 9y squared.
All right, hold on. Let's first of all make the problem a little bit easier by writing it like this. Correct? That's what that means. X minus 3y quantity squared means x minus 3y times x minus 3y. Now, FOIL those.
Okay. So x squared minus 3 xy minus 3xy minus 9y, or plus 9y squared.
Okay. Which answer is that?
Isn't it just h?
What's that become?
Oh wait, never mind.
Besides that, h has got the wrong sign. It's got minus 9y squared.
Yeah.
In other words, you have to combine those two like terms in the middle, which is very often the case. Yes.
So -6xy?
Uh-huh. So the answer is G.
Oh, okay.
In other words, when I combine those, I got -3 minus another 3. That's -6. They're both apples, which in this case is an XY. That is an apple.
Okay.
Okay. 13. If x is an odd integer greater than 5, what's the next greater odd integer in terms of x? That's where your terminology comes into play. You need to know what an integer is. You need to know what an odd.
Isn't integer just a solid number?
Whole number, yes. In other words, no fractions, no decimals.
Mm-hmm.
The integers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And actually, they go negative also. 0, -1, -2, -3, and so forth.
Would it just be C? Wait, no. Wait.
Here's a really good one. Okay, here's what we're looking at. We're looking at a variable in the question, and we're looking at every single answer has that same variable. When you see that, you know you can pick numbers. Give me a number for x. You can make it up, as all you got to do is follow the rules. It's got to be an odd integer, and it's got to be greater than 5.
Okay, 7.
What's the next greater odd integer?
9.
Now, which of those answers gives me 9 when I plug in 7 for x?
A.
Yeah. And that's the way you do it. In other words, when you pick numbers, I'm not quite sure why it is, but the brain knows how to do it better than the algebra formation. Okay? So the moment you gave me 7, well, now the brain knows that if x is 7, the new number, question mark, is the next greatest odd integer, 9, which is 2 greater than 7. And in fact, this is a pretty common problem. They won't always be odd. Sometimes they'll be even. If I were to list even numbers, even integers, well, no matter what it is, the first one's going to be x, the next one's going to be x plus 2, the next one's going to be x plus 4. You see the picture?
Mm-hmm.
And if I'm listing odd, and the first one is x, the next one is x plus 2, the next one is x plus 4. The other possibility, whereas they will give you consecutive integers, and if the first one is x, the next one is what?
X plus 1.
Yes, if we're dealing with consecutive integers. So those are the 3 types you're going to get, are even, odd, consecutive, and just consecutive integers. And so this x plus 2 actually shows up quite a bit. So does x plus 1, depending on the nature of the problem. Number 14. What are they really saying? Which of the following has the same graph? It means
like the same slope?
Which function is the same, right? Got to be exactly the same. Well, it's got to be a manipulation of this. Well, that certainly isn't it. X minus 8y is not x plus 8y. So you can eliminate that one. one is it? See if one of these equations is a multiple of this equation. Is any equation...
Oh, J.
Which one?
J.
Yep. J is exactly 3 times bigger. Every term, that's 3x, that's 24y, that's 9. And remember what the rules of algebra are. I can multiply the same as long as I can multiply by any number as long as I do it to both sides. And in this case, they've merely multiplied both sides by 3. All right, 14. Let's continue after this one. These are good degree of difficulty. By that, I mean medium. Whenever you see an age problem, these are perfect for back solving. The moment I even see the word age, my mind starts thinking back solving. Or things like Bill has 3 more marbles than Tom. Tom has twice as many marbles as Jane. How many marbles does Bill have? Questions like that.
Okay.
Okay. Where are we going to start? If we automatically recognize that as a back-solving problem, which one do I start with?
C.
C?
Uh-huh.
All right, that's what Sycamore Learning Company teaches, and I'll let you get away with it. It's not really the best one, but okay. So, Anne is 12 years old, right? In other words, it's always that. How old is Anne? Well, you're saying Anne is 12. Now, Anne is 3 times as old as Kylie, so how old would Kylie be?
4.
If their combined age is 24, is that 24?
Nope.
Do we need to have a bigger or a smaller age for Anne?
Bigger.
Okay. So we ruled out that. Now, one more trial should answer the problem, right?
Mm-hmm.
So which one would you try?
Probably 18.
All right. So Anne's going to be 18 in this case, which makes Kyle how old?
6.
Aha, bingo, we got it. The combined age is 24. 18 is the answer. Now, if 18 would have been not the answer, we would have known 24 was the answer. We'd have been done with the problem and we'd have gone on. Although, there's usually an extra trick or two with these things, and this one has it. You can almost eliminate that immediately, right?
Mm-hmm.
Because their combined age has to be 24. So I'm not ever even going to try 24. I know that that can't be right, not unless Kyle is 0, and then even then it wouldn't be right, because 24 would not be 3 times 0. Now, when I said that Sycamore Learning was not correct, the correct place to start is either the second highest or the second lowest.
Okay.
Now, had I started with the second highest here, 18, I would have got it on the first try, accidentally. If I would have started with 9, well, then I'd have been adding 9 plus 3. That's only 12. I would have known I need a bigger number. The next one I'm going to try is B. If D does not work, then I'm going to try B. And B would either work or it would tell me the correct answer. I would then know it was either that one or that one if D or B don't work. And the only reason Sycamore Learning Company is wrong is because when you try this one first, you only get the right answer 20% of the time, right?
Mm-hmm.
If you try this one first, you actually get the right answer 40% of the time. Because whenever B is correct or A is correct, you're going to get it when you test B. Or if you happen to try D first, you're going to get it whenever D is correct or whenever that is correct. So 40% of the time, you're going to get it on the first trial. Whereas when you start with C, you only get it correct 20% of the time. It's actually a pretty big difference. The difference between getting it correct 40% on your first attempt as opposed to 20% is quite large.
Okay.
But C works okay also. The difference between that is not large enough to even worry about it. All right. Another problem that looks like parallel lines and transversals, right? I mean, that looks fairly parallel to that. I don't see anything that says it's parallel, so we'll have to read the problem. But undoubtedly, this is a problem about parallel lines and transversals.
Okay.
Lines PQ and ST are parallel. And the rest of the material is already on there. They tell you that one's 65, that one's 85. What is the measure of this angle right there? It's a one-step process. This is one of your few geometry problems where you can get it in one step. I have two parallel lines and a transversal. Remember, all acute angles are equal to one another. All obtuse angles are equal to one another.
So would it just be 65?
You got it. In other words, those are the alternate interior angles like that. And what you kind of want to do is eliminate that line from your thinking. And that angle is totally unnecessary. It's kind of a good example of where they give you a piece of information that's kind of meant to throw you off. Is all my picture needs are these two lines, these three lines, excuse me.
Okay.
Those are my parallel lines, and that is my transversal. That's an acute angle, that's an acute angle. They have to be the same. Okay, this is a medium problem. I can clearly try to figure out how to express this algebraically, but this has another flag that tells you what the right way to do it is. What's the flag?
I'm not sure.
What is it that we see here that makes this ideal for a particular method of solution?
I'm not sure.
You see a variable in the question, and every single answer has that same variable in it, D. And what that means is that D can be anything. They're not telling us what D is. So let's make up a number for D.
Okay. Does it matter what number it is?
Well, read the first sentence. Carrie has $7 less than Steve, who has D dollars. So I need a number bigger than 7, right? What is it?
So 10.
10, okay. So, which of the following is an expression? Oh, hold on one moment. Carrie does not spend any money and earns $3. So Carrie started with 7. Her brother Steve started with 10. And now if Carrie earns 3, what has she got?
10.
So now Carrie has 10. Steve still has 10. Which of the following is an expression for the amount of money that Carrie has? So we need whichever answer equals 10. We know that Carrie has 10. And by whichever answer equals 10, I mean given a starting D of 10. That's not good. Hold on. I did something wrong. Carrie has $7 less than Steve. So we gave Steve 10. We gave Carrie, there's my problem. We didn't do the math right. Here, let me start over again. That's always a bad sign. It's very hard to get the answer right when you do the math wrong. If Steve has 10, Carrie has to have $7 less. Now Carrie earns 3. So Carrie now has 6. So which expression over here is going to equal the number 6 whenever I let D be 10, which is the amount that Steve has? So if I fill in 10 for D, which answer is equal to 6?
D.
Exactly, and it's the only one. This one's equal to 5, that one's equal to 14, that one's equal to 0, this one's equal to 6. And notice, I didn't have to do any algebra. My brain knew that if Steve was 10, Carrie had to be 3, or at least it should have. I made the mistake the first time and made her 7. But in other words, the reason picking numbers works so well is that your brain knows how to solve that problem really easily. It doesn't know how to set it up as an equation really easily. That's not the same thing. But if I give you an amount for Steve, your brain knows how to figure out what Carrie has. If I said Steve has 15, how much does Carrie have?
Eight.
Okay. And now I'm looking for which answer is equal to 8 given a D of 15. D is equal to Steve's age, which we're saying is 15. In other words, I can pick any number I want as long as it's bigger than 7, more than Carrie. In other words, I wouldn't be able to call Steve 6 because then Carrie couldn't have $7 less. And it's not their ages, it's the amount of money they have, but notice it doesn't matter. I could just as easily say that Carrie is 7 years younger than her brother, and then no, that doesn't quite work with age, because she can't age 3 years without Steve aging 3 years. So that's why they use dollars here.
Okay, wait, so, wait.
Yeah, let's get this straight. This is a very, very important principle.
So let's say I did choose 15 instead of 10.
Okay, so
That means Carrie would have.
D is Steve's amount, which is 15.
Oh, wait, I got it. Because if
Carrie
you
is
add 3 to 8, then it would still be.
It would have to be 8. Carrie earns 3, so the new Carrie has 11. So now I would want to find which answer is equal to 11. Well, I guarantee it's the same one, D.
Yeah, that makes sense.
15 minus 4 is equal to 11. So that's the secret of picking numbers, is you can pick any number you want. Just make sure you can figure out what Carrie's new dollar amount would be. And then we look for one of those 5 answers that's equal to 11, given a D of 15. So we've taken a relatively hard problem and we've actually turned it into an easy problem, which is usually the case when you use pick numbers. The problem is that people don't usually know where to use it. And the one place that it's always very usable is when the variables in the problem are all in the answer. And you can have multiple ones. There may be 2 variables in the question. And then every answer would have both variables. When you see a question like that, think pick numbers.
Okay.
About 18.
Okay.
So here, let's write it out. Very, very straightforward algebra problem. However, if you don't know how to do the algebra on this, what's another way to solve it?
Plugging in numbers for A.
No. We see A's in the question, but we don't see A's in the answers. So this does not fit the same flag that 17 had.
Oh, okay.
However, we can back solve it, right? I can pick some of these answers. Let's start with the second lowest and see if that works. Is that an equation when I use 5? Well, 0.2 times 5 is 1 plus 1.8. Is that equal to 5 minus 2.2? Well, I'll be darned. It worked the first time. There's your answer.
Okay.
However, this was not really the ideal problem for back solving. Had this not been an equation, I'm not sure if I would have needed a higher or a lower number. I wouldn't have known for sure. In other words, let's try, I'll show you the difficulty. Let's try the other place we could have started, which is J. Okay? If I start with J, then 0.2 times 12 is 2.4 plus 1.8 equals 12 minus 2.2. Well, now I got 4.2 equals 9.8. Well, that certainly is not correct. Furthermore, I don't know if I need to go up or down. So it's not ideal for back solving. Where back solving is always the shortest way to do a problem is when whatever number you pick, if it's not the answer, at least you know whether you have to increase it or decrease it. That's a huge thing for back solving to be valuable. Now, that's not to say that if somebody said to you, your life depends on getting this correct, you just go ahead and try all 5 answers, right? And you'd get it. You'd find one of those 5 that work. However, it's troubling to me that you don't know how to do this algebra. What do I got to do here? Let's solve this algebraically. You need to know how to be able to solve this algebraically.
Okay.
What do you do when you have an equation where I've got some variables on the left, I got variables on the right, I got numbers on the left, I got numbers on the right?
Just
gather all like variables. Gather all of your A's together. Gather all of your numbers together. Now, the first question you have to ask yourself when you're doing that is, am I going to put the A's on the right side or on the left side? In this case, which side am I going to put it on?
I would say the left side.
If I put it on the left side, I'm going to have a negative coefficient, which is okay. So I'm going to subtract A from both sides. What does that give you on the left? What is 0.2A minus A?
Is it just 0.2?
No.
Or, sorry, 0.2A.
Hold on. What is 1 minus 0.2?
Um, 0.8.
Okay. Well, this is a 1 right there. Only I had it on the other side, so the problem was really 0.2 minus 1, which is negative 0.8. So I got negative 0.8A, which if I'm putting my A's on the left side, then I got to put my numbers on the other. I'm moving that to there. Now I got negatives in front of both, so that's okay. But I can tell that A equals 4 divided by 0.8. Well, that's 5.
Mm-hmm.
Now let's back up one step. I don't like negative numbers. I've never seen a student yet that was better with negative numbers than they are with positive numbers. So when I'm trying to decide which side to put my variables on, I'm going to put it on the side that results in a positive coefficient. I'm going to move that to the right, and I'm going to move that to the left.
Oh, yeah. I guess that would be faster.
That helps a little bit because now I got A minus 0.2A on the right, which is 0.8A, positive coefficient. And on the left, I get a positive 4. So I have no negative coefficients. And that always removes the chance for error. Error comes about, negative signs cause people to make errors. So if you have a choice as to either use negative signs or don't, go with the don't.
Okay.
I didn't need to use negative signs here. I just needed to decide that I've got to move my variable to the right side in order to have a positive coefficient. Never, when you see an A, remember there is always a 1 in front of that A. And 1 minus 2/10 is 8/10. All right. Let's look at 19. One thing we do seem to get is a lot more problems per page here than in that book where we were working the other day. I was only getting like 2 or 3 problems per page in that book, whereas now we're getting like 6 problems per page.
Yeah, true.
These are smaller questions. They're not 7-line questions. Okay. 19. How are we going to solve this?
Can you just plug in or back solve like the
Back
numbers?
solve. Where am I going to start?
B.
No. This is
C.
different. No. This is different because it says that. So,
so 2.
I want to start with the smallest one. In other words, if I start with 5 and it works, well, I don't know that that's the smallest one. 4 could work, 3 could work, 2 could work. So when they ask for a specific smallest or largest, you want to start there. In other words, if I start with 2 and it's correct, I am done. There's no way 3 is the correct answer. Okay?
Okay.
So, what is the approximate square root of 8? You can use your calculator if you want. Probably is the simplest way to do it.
2.8.
So negative 2.8, right? The negative sign is outside the radical, so it stays there. Plus 2.
Is negative.
That is negative.
So 2 works.
2 is the answer. If I would have started with 6, first of all, it wouldn't have worked. But even if it would have worked, I wouldn't have known it was the answer because maybe 5 works. That's why we got to start with smallest. Is because you won't know if you have the right answer if you start with, even if I start with 3. 3 could potentially work, although it does not, actually. So the only one that works is 2. But that wouldn't be the issue. You could definitely have multiple answers that work here because they asked for which is the smallest answer. All right, number 20. What's a good way to do 20?
Back solving?
Yes. You're going to be amazed at how frequently you can use back solving. I mean, we've run into every problem on this page, I believe. You could either solve it with back solving or picking numbers. We didn't have to come up with any algebra at all. It was all done in our head. Okay? So here's our piece of rope. That's 30 inches. We cut it into 2 pieces. Okay? The total of those is 30 inches. They are in a ratio of 2 to 3. What is the length of the longest piece? Well, because it says longest piece, where am I going to start?
The shorter one? I don't know.
Longest. Where am I going to start? What's the longest?
The 3.
We're back solving this.
Oh, I'm sorry. I was thinking the wrong thing.
Okay. So we're going to start with the largest number. 18.
Okay.
So we're saying that that is 18. Well, if that were 18, what would this be if they're in a 3 to 2 ratio? In other words, I have to maintain the 3 to 2 ratio.
15. I'm not sure. I'm not really good at with the ratio stuff.
What is that equal to? That division?
6. 6.
Okay, so this has to be 6 times bigger.
Okay.
In other words, those 2 ratios have to be the same. They have to both be 6. Now, in other words, 18 to 12 is the same ratio as 3 to 2. Is 18 the correct answer?
Yes.
Yeah, because
No.
18 plus 12 is
Oh,
30.
because it equals 30. Yeah.
You cut a 30-piece inch of ribbon into 2 pieces. So 18 and 12 works perfect.
Okay.
I'm not even sure I needed to do that. That might have actually confused you. The key is they're asking for the longer piece, so we're going to start with the biggest number. If the longer piece is 18, well, that automatically would make the shorter piece 12, right, if they add to 30. Now the question is that a 3-to-2 ratio? The answer is yes. Does it matter that it's not a 2-to-3 ratio? No, because they said what was the longer piece. The longer piece has got to be the bigger of the two numbers. And that is in a 3-to-2 ratio or a 2-to-3 ratio, whichever way you're looking at it. But nonetheless, the longer piece has to be the 3 part of the ratio.
Okay. That makes sense.
That's a good place to stop. Haley, good luck.
Thank you.
Get a good night's sleep before the test.
Try.
All righty. I will talk to
Okay.
you later. Bye-bye.
Okay. Thank you so much.